Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. So in this video we are going to learn about mobility in semiconductors. Okay, so we are going to learn about mobility in semiconductors. If you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so first point which you have to remember is what is mobility. So mobility indicates how fast charge carriers, I am telling you the charge carriers, which means both electrons and holes. Okay, so how fast charge carriers are moving inside a semiconductor from one place to other place, from one place to another place. Okay, so how fast the movement happens for both electrons and holes is given by the term mobility. Okay, so second point is what is the formula for mobility or representation of mobility. So mobility is represented by mu. Okay, so if it is for electrons, we'll represent with mu n. If it is for holes, we'll represent with mu p. Third, after representation, formula. So what is the formula for mobility? So mobility mu is given by drift velocity divided by field intensity. Okay, so always moment is due to drift. So drift velocity, how much you are applying within a given field intensity, is given by the term mobility. So it is Vd by E. Okay, so drift velocity. So fourth is units. What are the units for mobility? Okay, so the units for this velocity we know that units is meters per second, and for field intensity it is volt per meter. So meter per second into meter by volt. So meter into meter will become meter square by volt second, or centimeter square by volt second. So these are the units for mobility. Understood? So that is the thing. Next, fifth, what are the values of mobility? Very important. So what are the values of mobility for germanium and silicon, at least for germanium and silicon? Okay, so these are the standard values. At 300K, that is at room temperature, I am writing in tabular form. So this is mu n, mu p, this is germanium and silicon. So here it is 3800, this is 1800, this is 1300, and this is 500. Okay, centimeter square per volt second, centimeter square per volt second. So these are the values which you have to remember for UGC NET exam. Very important. They may ask you germanium, what is the value of mobility of germanium or electron mobility of germanium at 300K? So it is 3800 centimeter square per volt second. So always units also very important. Okay, so just remember that. Next, sixth point. So for germanium, how will be the relationship between mu n and mu p? Okay, so for germanium, mu n by mu p is 2.1:1. That is, mu n is equal to 2.1 times mu p. And for silicon, mu n by mu p is 2.6:1. So always we have mu n greater than mu p, therefore always current given by electrons is always greater than current given by holes. This is the reason. Okay. Seventh, so mobility always decreases. Mobility always decreases with increase in temperature. With increase in temperature. This is very, very important point. So mobility relationship with the temperature. So as temperature increases in semiconductor, so mobility is going to be decreased. Okay. So mobility is proportional to T power minus m. So it represents 1 by T power m, of course. So decreases with increase in temperature. So that we'll call it as NTC, negative temperature of coefficient. So mobility has negative temperature of coefficient. That means mobility decreases as temperature increases. So negative relationship. So that is why it is NTC. Okay. So this happens because as we increase temperature. So if you increase temperature, what will happen? So mobility increases so fast. So all the charge carriers move fastly inside the semiconductor, right? So due to which collision happens. Okay, so due to this thermal vibration, so what will happen? Collision of charge carriers occurs. Collision of charge carriers occurs, and thereby the velocity gets decreased. Velocity gets decreased. So that is why always mobility will have negative relationship, that is NTC. Okay, so this m value is 1.66 for electron and 2.33 for hole in the case of germanium, and similarly this m value is 2.5 for electron and 2.7 for hole in the case of silicon. That means it will have a non-linear variation. This is also very important point. So always mobility will have a non-linear variation. It is not linear. Okay, so non-linear variation with respect to temperature. So mobility will have non-linear variation with respect to temperature, and it will have negative temperature of coefficient. That is, as temperature increases, mobility decreases. Okay, so these are the important points which you have to remember regarding mobility in semiconductors. Okay.